Alright, so here we're going to be talking about the law of sines. This is something that you have seen before, so again, I'm going to expect you to kind of have some knowledge about this. But if you are confused, as always, you can make sure you ask questions in class so that everything gets straightened out. Okay, so our objective, understand how and when to use the law of sines. First, what is the law of sines? Well, so far we have dealt with right triangles. So now we're going to focus on oblique triangles. What is oblique triangle? Well, according to dictionary.com, great resource, use your interwebs, oblique is neither perpendicular nor parallel to a given line or surface, slanting, sloping. See more. That part you probably didn't need. Anyway, but basically it's just not a right triangle. However, I do want to make sure you understand that the law of sines will also work with right triangles. Because the sine of 90 degrees, or pi halves, is 1. So that should make sense when we see the law of sines. So the law of sines, as we've seen before, is a over the sine of a equals b over the sine of b equals c over the sine of c, or sine a over a equals sine b over b equals sine c over c. Now, a lot of times people think, wait, are there two different versions of the law of sines? Are there actually two laws of sines? What? Because it just says the law of sines. And yeah, that's because this is still the same thing. The version right here, the top version, is just the reciprocal of the bottom version, or vice versa, however you want to think about it. But it is not two different laws of sines, it is still the law of sines. It's the law, really, is what you want to remember. You should always follow the law. So, anyway, what does this mean? Well, we use the little letters, or the lowercase letters, to denote sides, where the larger letters are, or the capital letters are, angles. And that should make sense because we always take the sine of an angle, right? We don't take the sine of a side, because the output of the sine of an angle is the ratio of sides. We all understand that, I know. So why do we even care about writing these in two different ways? Well, if you're trying to solve for a side of the triangle, using this version is going to save you one step algebraically. If you are trying to solve for the angle of a triangle, using this version, or the reciprocal of the other version, is going to save you one step algebraically in your process. But again, either will work. They are the exact same thing. They are not two different laws. They are one law, and the law is the law of the land. The law of the land is math. So, let's talk about when can we use the law of sines. Well, there are three scenarios where we have enough information to use the law of sines to solve a triangle. When we talk about solve a triangle, we're talking about finding all of the missing sides and angles to the triangle. So, of these 6 scenarios of triangles where we're given 3 pieces of information, one of them is side-side angle. That is what we call the ambiguous case. That's going to be another one of your videos today. And that is one scenario where we will use the law of sines. However, based on looking at how the law of sines ratios are set up and your understanding of triangles from geometry, I want you to figure out what are the other 2 scenarios out of these choices down here where the law of sines will be applicable. So I want you to take a second and circle what you think. Pause the video. Okay, because hopefully you got that right, because I'm going to put you on the spot tomorrow and make you really uncomfortable in class answering that question. And by you, I mean everybody. So, I want you now to apply the law of sines to this problem. So find the missing sides and angles. So we have angle C, side C, and angle B. So I want you to find side A, side B, and angle A. Pause the video and do that. Unpause when you are ready to check your work. Alright, so this is what I did. This is not the only way to solve the triangle. In this case, we actually had options of what we could do first. But I chose to find angle A first, and if I know 2 angles in a triangle, then I can just subtract those from 180 to find the third angle. So 180 minus 40 minus 105 is 35. Now I used side C and angle C as my given ratio to find side B, knowing angle B. So 20 over the sine of 105 equals B over the sine of 40. Through a little bit of algebraic magic, I end up with 20 sine 40 over sine 105. Type that into my calculator. Side B is 13.309. Again, unless you are otherwise told, you always want to round to 3 decimal places. That's something we've already talked about this year. Next, I found side A. 20 over sine of 105 equals A over sine 35. 20 sine 35 over sine 105 equals A. So A is 11.876. We don't have any units here, otherwise we would want to write our units, but we don't have them. So that's it. Another thing I want to point out, so anytime you are given values, you should probably use the given values over any values that you solved for. So for instance, what I mean is instead of doing 20 over sine 105 equals A over sine 35, I could have also done, let's get my pen out, 13.309 over the sine of 40 equals A over the sine of 35. The reason why I don't want to do that, if I can avoid it, is because this number here, 13.309, that's a rounded value. And I want to try to keep exact values as much as possible, so using given information where it's not rounded will help me do that. Okay, so again, law of sines, it is just one law, law of the land is math. Solving for a side, have the sides on top. Solving for an angle, have the angles on top. It'll just save you one step algebraically, but really it doesn't matter. Go on to the next video.